Hey, my name is Amy, and today I'm going to talk a little bit about the Marriotte bottle and the first steps of the experiment for this class. This class is physical experimentation and statistical thinking, and therefore we have to do this project with all the elements we have studied so far. So, first of all, what's the Marriotte bottle? Well, it is a bottle, as the name says, that has two holes in it. Like mine, it has one hole here, oh, here, and one hole on the cup. And it's relevant to this day to really study the flow of water under a constant and equal height. So, for example, in which situation can we study this? Well, we all know the rotoplasties that are over some people's homes, and these things really embellished um, this knowledge. So, going on, we can study a lot of things with the Marriott bottle, such as the velocity of the effusion of the liquid, how um, how it really helps to really emulsify all the water situation in a house, and it's a really important topic nowadays. There's also in FED a way to experiment it virtually, and it's really cool, but we're not going to talk about it today. We're just going to focus on our experiment. So for this physical theory, we also have the Pascal principle and the Torricelli theorem, and we're going to talk about this on the next video for the part 2 of the experiment. But it's important to mention them because they are relevant for the experiment in general. Okay, what are we going to need for the experiment? Well, basically we need a bottle, a straw, and a hose. I have already shown you mine, and that's more or less what we're gonna do. And I'm going to show you a little bit more about what it is. So for this part, we are assembling our Marriotte bottle, and we are making the holes and putting a straw and the hole in there, and it's removable so we can do tests better. So yeah, that's pretty much it. And yeah. So for this part, we are only using the bottle itself, and it's really fast, and it goes really far. For the second part, we are using a straw, and we see it's a little bit more constant, and it's a little bit slower than the last one, but it also is fast compared to the next one. Finally, we have the straw and the hose, and we can see that it's pretty much shorter, the line, and it's mostly because of the straw, and we understand that's like a dead space. But it's important to mention that it's also the lowest by far. I mean, just see how much I have been talking and how much I talked in the last ones. It's insane how much time it takes to drain with the straw, without the straw, and with the hose. So yeah, pretty much it's almost done, but it's pretty long. So finally, let's talk about conclusions. We have seen that the environment of the bottle, the construction of it, the amount of water, the straws, the holes, everything contributes to the result. As you have seen the results in my report, they vary a lot. And also in the last videos, like they are very, very different from one another. And it's insane how we use the same amount of water. They're in the same space physically, but they have different components that um, actually get to the point to impact hugely in the results we have. And therefore, I would just want to talk about the fact that it's again the margin of error is so different between all the things that you're using, the utensils, the ingredients, the amount, everything. And it's always going to be maybe a little bit more or a little bit less water, because we cannot be 100% sure that the same amount of water was used in all three videos. So it's really important to make this something relevant for further experiments, further studies, and to make this something an experience, and to acknowledge everything we have acquired in order to fulfill our professional needs in the future, to make us better professionals in each of our areas, and therefore learning from every subject we have had. So that's me for today, and I hope it was a good project. And yeah, thank you. Well, that was all. I hope you really enjoyed it, and thank you.